So, my dear student, today I am going to make one more project, that is using your temperature sensor. Now, let us start. So, the approach is same. First, create new circuit. Go to this tab, creating new circuit. Click on that item. Now, this page is open. This is the workspace over which we can make our desired project. So, doing this project, we need some component here. The first one is Arduino Uno, as you know. Then we'll take one temperature sensor. We have that one. Okay, in this component ID. So we'll use this temperature sensor, that is TMP36. Okay, then we'll take one breadboard. So this is our Arduino Uno. Take breadboard, place it. Now, as I mentioned you every time, it's a good habit. Always you keep plus 5 volt here and ground potential here. Okay, for general purpose use. So that I will do first. So that connection is this sort of connection. So just you for the general use, you use this red color. Generally, we prefer plus 5 volt as red color and ground as black color. So we'll follow that convention, nothing new. Okay, and this may be black color. So hope you will understand. Now we'll take one temperature sensor. This is your temperature sensor, TMP36. So this is your power, this is your V out, and this is your ground potential. Okay. So as it is power, so make 5 volt connection here. Take red color, and this is your ground potential. So connect here, change the color. So connection is done. Okay. Now see, temperature. It's a analog sort of sensor. Okay. In our previous project, we had PIR sensor, and that was basically your digital sensor. So that's why output was connected any one of the digital IO pins. But here, as it is analog output, so we'll connect it any one of the analog input. So it is A0. Because you people know that these are analog input. Okay. So change the color first. So basic circuitry is done. Okay. Basic circuitry is done. Now we have to go for coding purpose. So see the circuit. I'm zooming it. See, it's a simple circuit. This is your power. So power supply connected. This is your ground. It is connected to ground potential. This is your V out, analog out. So that is connected here, analog in. Okay. So now we have to study. We have to read this value. We have to read these values. Okay. What we are getting at this analog input. So let us go for coding. This is simple coding, as I mentioned you. Okay, don't worry about that. So come to the coding part. As I do, make it block plus text. So it's a default code. You just delete it. Now see, this is the left side space. Here we put all the blocks, required blocks. Okay. Correspondingly, at the right size space, code will be generated automatically. We need not to write any code here. Most of the cases. So this block, basically the fundamental block, always it will come. Now you have to modify, you have to write your code accordingly. So now see here, read temperature sensor on A0. Okay, so this is your block you need to have here. Is the temperature sensor pin on A0 already, or A0 is by default? Okay, you need degree centigrade and Fahrenheit. As per your choice, you can change that degree centigrade. Okay. So before doing go for simulation or further coding, we take one variable here. Just like your ultrasonic, we have taken US. Simply we take a temp, TEMP, temp variable. Okay. So temp automatically temp and these three blocks will be generated every time when you are going to design any sort of going to create any sort of variable. Okay. So just I'm start again starting delete it. So that means we have made variable temp. So see, in the coding part, automatically temp is equal to 0 int. Variable type is integer. Temp is equal to 0. Initial initialization is 0. Okay, and it is a global variable. Why it is global? Because it is beyond the loop. Okay, it is in the beginning of the program before void setup. Okay, so that's it's a toolbar. If you use any variable within these blocks, these are local variables. Okay, but this temp is equal to 0. It's a global variable. Now, okay, now see, we take this block. Just put it here. Now, देखो, what is the change here? Void loop. As soon as we place this block, okay, temp is equal to 0, and this is a delay, a little delay is there. It was previously there. So temp is equal to 0 because temp to 0, isn't it? Now we are going to measure the value at A0. So that's why we take read temperature sensor. We'll put it here. Okay. As soon as we place it here, so now whatever you are taking sensor value at A0 will be stored at temperature variable. So temp is equal to, there is a relation. Okay. This is the whenever you are going to purchase any sort of sensor, so by default there is a calibration formula on the data sheet. Always you will get. Okay. So you can copy this, okay, for future use. So I am keeping it. Okay, I'm keeping this one. Okay. So I already written that value. See. Okay. So I'm okay. So for future use, you can use it. So now you have to, okay, you have to observe. Okay, you have to see the data. Okay, for that every time what we do, we use serial monitor. This serial monitor we use. So print any data. Okay, we'll use which block? Print serial monitor. This block we'll use. See, as soon as we place it, what happens? Okay, see here. Okay, I'm deleting it. Now see, as soon as we place this read temperature sensor on pin A0, this block, then what happens? There is a change. Pin mode A0 is input. Now defined A0 is considered as input. Okay, and automatically this expression was there. Now for print, we'll use this block. So see, as soon as we place this, code will be automatically generated. What comes? This comes. Serial begin 9600. This is the baud rate. It will always be 9600 in our case. And serial println hello world, because there is written hello world. If you write here, uh, see, if you write here project on temp sensor, so see, automatically that thing is coming here. So if you want to print anything, so you have to place here that value. So what we are going to write here now, delete. So that means nothing is there. But we want to print what value? The sensor value. That is the temp value. What we have stored in temp will print. So take this variable temp and put it here, and automatically see temp comes. A temp, whatever the value here, that will be printed. So that is the case. Now this much coding is required here. Now we'll change it only block and start the simulation. See the serial monitor. See, value is 20. Okay. Now see, if you are changing. Okay. So see, 96 is there. So that means whatever you are getting this value, these are in degree centigrade. If you vary this one accordingly, it will vary. Okay. So so it can be used as digital thermometer. Okay. It may be the digital thermometer. You can use this one. And in COVID situation, to measure the temperature of any patient, we can use. So, so beautiful sensor it is. Okay, now we'll do some few more work here. Now, uh, I want to show you if the temperature is uh, beyond 50 degrees centigrade, then LED will glow. LED will glow. So for that purpose, you need to use one LED. Okay, so use LED. This is LED. Every time we are using. So place it. This is your cathode. This cathode is grounded always. So this is black. And this anode, there should be one resistor that is plugged. Otherwise, this LED will burn out because high current will flow through the LED. To avoid that problem, okay. So LED will fly. LED will burn out. That's why you have to use here. And it may be in the order of ohms, and it should be 220. Generally, we prefer 220 standardized data. Now you connect any one of the digital pin among your 13 pin. Okay. So use any one. So let us use pin number 2 here. Okay. So now change the color here. It will be yellow. So circuit is complete. Okay. So circuit is complete. You can see it. Disagree. So this is positive anode. Okay. LED is nothing but it being cancelled out. Okay. Cathode means 10. So we have completed the circuit. Now come to the coding part. Okay. Now come to the coding part. Okay. So here, as we are taking some decision whether LED will glow, LED will on or off. So that's why you have to take control value here. If then else. So this block. So just take block plus text for your better understanding and off it. Setting monitor. Now see what changes occurs. We use this block. So as soon as I am placing it, see this block automatically comes. After this serial printing. Okay. After this serial dot println tag. If something is there, then it will happen. Otherwise, else some other will happen. So And repeatedly I am telling you, this block, if dash then means if the temperature value is greater than 50 degrees centigrade, then LED will glow. So greater than what is the type of parameter here? What is the operation here? Mathematical operation. That means the comparison is there. So that's why we use this block here. Now there is two parameter, this and this. So here you have to put value of temperature. So that means use this variable, duplicate it and place it. Now see what happens if temp is less than 1, because there is a 1. So we'll change it greater than, okay, and value what I told you 50. So now see what happens if temperature greater than 50, then what will happen? I did not give any command. I'll give you now one command, that is output. Set pin digital write 0 high. So that 0 is replaced because see here this this positive anode pin is connected with pin number 2. So pin number 2, that's positive, we have to send high value to make LED on, and make LED off. Pin number 2, you have to provide low value. So accordingly you have to change this pin number 2 high. So see here in the code, digital write to high. So pin number 2 we are sending high, so LED will glow. Else if temperature is not beyond 50 degrees centigrade, then what will happen? Duplicate it and place it. Else pin number 2 will send low. So this is else digital write to low. Okay. So this is your code. This is your programming. Nothing complex. Okay. So now you make only block for better understanding. Now start the simulation. See the serial monitor. See, this is below 50, isn't it? 24. That's why LED is off. Now change it. 64. So that is beyond 50 degrees centigrade. So that's why LED is on. So in the place of LED, you can use some sort of alarm. Some sort of alarm. Okay. So suppose you have applied, okay, this sensor to a particular type of patient, and if his or her body temperature is go beyond the critical limit, so an alarm will ring, uh, and the health worker will understand uh, that some thing happening there. So then they will take some action. So this is simple circuit. Later we'll go for some in our I have planned so much. In future we'll go for some IoT applications. This temperature, what I am showing here, that will go to your mobile phone. Okay, so if doctors remain far away from the hospital or the patient, but automatically doctor will see what is the body temperature of the patient, not necessarily body temperature. The doctor he can monitor his patient's blood pressures. Okay, some others component also, other parameter also, other physical parameters also. So this is the thing. Now you can change this temperature 50, so you can change it 40 also. Okay, so you can change 40 also. Now simulate. So again, see if it is greater than 40. Now this is 24, so that's why it is off. Now change the temperature here. So LED is on. So very beautiful circuit is there, beautiful project is there. So this is the circuit. If you have any doubts regarding this project, okay, you can write your queries uh, at our YouTube channel, and I will give your answer. So hope you have enjoyed the session. And later, what we'll do, we'll interface one LCD here in our next project. in our next class. Okay. So thank you.